Hello kids, in the previous classes we had already discussed about progressive waves, and as you know, every wave has a characteristics. Out of the 5 different characteristics like amplitude, frequency, time period, velocity and wavelength, one of the most important characteristics is our amplitude. What amplitude is? Amplitude for a wave is the maximum displacement from the mean position. If the wave is a longitudinal one, then it must be moving like this. So during its compression, say this is the mid position, during the compression it is coming closer, and during the rarefaction it expands like this. So what is the maximum expansion from the mid position that can occur during the rarefaction? That will be the amplitude. What is the minimum displacement during the compression from the mean position? That will be an extreme. So similarly, when we talk of transverse waves, during transverse wave motion, the particles oscillate around their mean position. Sometimes they go up, sometimes they come down. So while going up, they start going up like this and reach a maximum stage. Then they come like this and then they reverse their direction and again they go like this till they go to the extreme position and then they come back. So this is the way how transverse wave motion works. And in each case, whether it is a longitudinal wave motion or it is a transverse wave motion, in both ways we have the maximum displacement from mean position is known as the amplitude. So if we take a transverse wave, we can clearly see that these 2 points have come far away from this mean position, this line. So this one is known as the amplitude. What amplitude is? Amplitude is the maximum displacement from the mean position. Where is the mean position? We can see that this on this line every point is in mean position, but here the particles have gone up due to the energy of the wave. The particles are pulled upwards and the maximum height to which it is pulled up, or the minimum or the extreme displacement that it has pushed down. So this pushing down, the maximum of the pushing down, if we count it, this is the extreme displacement downwards, this is the extreme displacement upwards. This maximum displacement will be called amplitude. So we can term it A here, we can term it A here. For a direction we can add plus here, upwards, minus here, downwards. So if this wave is represented by y is equal to A sin omega t, where omega t is equal to theta, then this A will be the amplitude of the wave, and for calculation of that we can consider, suppose there is a circle and there is a y-axis, there is a x-axis. If one boy is just rotating like this, another boy is copying its position here on this pillar. So as this boy goes up, this boy will go up and up and up and up like this. When the boy comes to this side, this boy has to come down to show the foot of the perpendicular. Like this picture, as the rotation takes place, the foot of the perpendicular goes up, down, down, up, down, up, next down, down, up, down, up, down. So this is the oscillation. So during oscillation, we can find the foot of the perpendicular oscillates. So in case of transverse wave motion, we can see this oscillation like this. This is going up, this is coming down. So the maximum displacement from the mean position becomes the amplitude of a wave, and this is very much helpful to understand what are waves, and this is our amplitude. So for listening it so nicely, thank you.